In this EdPuzzle, we're going to go over the Bohr model, both the electron configurations and electron transitions. So what is the Bohr model? Well, we talked about the different atomic models in our last section. This Bohr model was the fourth in our list of models. It is not the newest model, but it's almost the newest. And it's a very powerful model. The protons and the neutrons in this model, they're located in the center, which we call the nucleus. And the electrons are around the outside in defined orbits. And that's really what is important about the Bohr model. Those electrons are in very specific spots in these orbits or these rings around the nucleus. So in the Bohr model, it's really all about those rings. If I take an atom of, say, krypton, we can see the 36 protons right here in the center with that plus 36. The Bohr model is going to tell us where the electrons can go in those rings. But each of those rings can hold a different maximum amount of electrons. Our first ring, the smallest ring, can hold a maximum of 2 electrons. Our second ring, a little bit farther out and a little bit bigger, can hold a maximum of 8 electrons. Our third ring, a little bit farther out, can also hold a maximum of 8 electrons. And our fourth ring can hold a maximum of even more, 18 electrons. Now, there can be more rings, but we're going to stick with the first 4 in this class. Quick knowledge check. First, where are the protons located in the Bohr model? Those protons are going to be right in the center, in that nucleus. Where are the electrons located in the Bohr model? Electrons are going to be in these rings around the nucleus. I'm not going to place any just yet because I want to see our next question. Our next question asks, how many electrons fit in this first ring? In that first ring, we can hold a maximum of 2 electrons. I'm going to skip a ring though. How many electrons can fit in our third ring of the Bohr model? I'm skipping the second. How many electrons can fit in the third ring? The third ring can hold a maximum of 8. Just so we fill in our model, I'm not going to ask about the second ring, but it can also hold 8. And the fourth ring can hold 18. All right, let's talk about how to draw a Bohr model. Let's take an example of nitrogen. If I look on my periodic table, nitrogen has this 7 up here. Its atomic number is 7, which means that it should have 7 electrons when it's neutral. I'll first draw a nucleus for the protons, draw that in the center, and I'll put a plus 7 showing there are 7 protons. I'll then give myself some rings around the nucleus for my electrons. We'll start with one ring. Now first, we want to start placing electrons equally around the ring, starting at the top. We'll put 1 electron right here. Now here's the weird rule. The first half of any ring, the electrons go in as singles, and the second half will pair up. Because the first ring can only hold 2 electrons, the first goes as a single, and the second immediately pairs. This first ring is now full. But I still need to place 5 more electrons for nitrogen. So I can give myself another larger ring around the outside, my second ring. This can hold a maximum of 8, but I only need to place 5. 1, 2, 3, 4. The first 4 go in as singles, and that last one will go in as a pair. Now I think it's better to see this whole process right from the start. So let's redo nitrogen. 1, 2 in the first ring, and then 3, 4, 5, 6, 7. And that fills up my nitrogen. All right, now it's your turn. What does the Bohr model of beryllium look like? Here is the element symbol for beryllium from the periodic table. Go ahead and draw the model of beryllium. Your model should look like this, and we'll place our 4 electrons, 1, 2 in the first ring, 3, 4 in the second ring. That's it. Make sure this second ring, they're not paired because we're still not halfway full. All right, let's take a look at another one. What does the Bohr model of aluminum look like? Well, here's a template for you, and here's the periodic table entry. Go ahead and draw a Bohr model of aluminum, and you may need more or less rings than are shown. All right, for aluminum, we have 13 electrons, so let's start placing them. 1, 2 in the first ring, 3, 4, 5, 6, 7, 8, 9, 10 in the second ring. We have a total of 10 right now, 2 in the first and 8 in the second. We still need 3 more electrons, so let's draw a larger ring. 1, 2, 3. And that's it. Let's do one more example. What does the Bohr model of chlorine look like? Chlorine has 17 electrons and 17 protons. Give ourselves a template. We may need more or less rings. Go ahead and draw the Bohr model of chlorine. All right, the Bohr model of chlorine should have 1, 2 electrons paired in the first ring. 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second ring. And we need 7 more. Let's draw a third ring. 1, 2, 3, 4, 5, 6, 7 electrons in the third ring. That gives us our 17 electrons for chlorine. Now we have to talk about the energy in these electrons. Each ring is going to have a different energy level. But first, let's talk about protons and electrons. Opposite charges, such as protons and electrons, are attracted to one another. If I place an electron in this first ring, it's going to be attracted to those protons of the opposite charge. Electrons want to move towards the nucleus. They're almost like magnets, a negative and a positive. And the farther away an electron is from the nucleus, the more energy it has. This electron would have low energy because it's very close to the nucleus. This electron would have high energy because it's very far from the nucleus. Now, when electrons jump between different rings, they do so by either absorbing or giving off light. For instance, if this light wave, the orange light, comes in and hits this electron with a low amount of energy, it's going to give it a small jump because small jumps in ring level, such as from the first ring to the second, require small amounts of energy. However, large jumps require large amounts of energy. So if I look at a different electron and I hit it with light with a higher energy, it's going to jump more rings. It's going to jump maybe 1, 2, 3 rings. Let's talk a little bit about the energy in light. Different colors of light have different energies. For instance, red, if we look at our rainbow, red will have the lowest energy. And as we go through the rainbow, red, orange, yellow, green, blue, indigo, violet, the energy goes up, violet having the highest energy. So green's kind of in the middle, and our higher energy lights, blue, indigo, violet, and our lower energy lights, yellow, orange, red. And here's a scale of those colors, red having the lowest. And as we go to the right, we're increasing in the energy. All right, now it's your turn. If the electron in this left model jumps 1 ring when it absorbs green light, what is a reasonable color of light that will cause the jump in this model where it jumps 1, 2, 3 rings? Go ahead and answer on screen. There's really 2 different options here. Because the jump is higher in energy, we need a higher energy of light. So blue light or purple light would make sense because they have more energy than green light. All right, let's take a look at another example. Let's say in this example, orange light makes our electron jump 3 levels. 1, 2, 3. What color of light might cause a jump of 2 levels? 1, 2 in this right model. Go ahead and give me what color of light will jump 2 levels. In this example, only red makes sense. Because the jump is less in the right model, we need a color with less energy, such as red, the only color that has less energy than orange. Let's do one more. In this left model, I have my electron jumping 1, 2 levels when it absorbs blue light. And this time I'm going to tell you that the electron is absorbing purple light. So we have blue jumping 2 levels. What kind of jump will happen when this electron absorbs purple light? Go ahead and answer on screen. The only thing that makes sense in this model is for the electron to jump more levels because it absorbs light with more energy. So it would jump 3 levels. And that is the EdPuzzle quiz for Unit 2, Section 3.